Hi everyone, welcome back to my channel. Today I'm going to be talking about a very interesting plot that I think a lot of people are not really using it. However, it can be a really useful way of presenting your data. Today I'm going to be talking about violin plots. So the agenda for today's video is the theory behind violin plots, as in what are they. Then I'll show you how to make a very simple violin plot. I'll show you how to make a more sophisticated violin plot on categorical data. And at the end, I'll show you how to present a violin plot to an audience, which is super important. Before we go on, 2 points. Point number 1, all the code and the data is in my GitHub repository, and the link is down in the description. Number 2, if you have not already subscribed to my channel, please do, because that really helps me grow my channel. And if you like the content, please like it as well. Without further ado, let's keep going. So, the theory. Violin plot, the plot at the very bottom of my screen, plays a role such as the role of a box and whisker plot, the one in the middle. If you haven't seen my box plot video, the link is up the top right. Violin plots show the distribution of quantitative data across many levels, such that those levels can be compared. Violin plots can be drawn for one category or several categories. Let me give you a very quick example. Let's imagine we're studying the lifespan of males and females in a specific country. We want to understand, in this specific country, do males live a longer life or females? Violin plots can be very useful in understanding that data. But what is the difference between a violin plot, the down the bottom one, with a box plot? If you have seen my box plot video, you will know that box plot, these tick points in the very beginning, right here, the first quantile, here, the second quantile or the median, this one, the third quantile, and this one, which is the max, they have a special meaning. They actually are calculated based on the data. However, in a violin plot, the shape does not have specific value. However, it represents the kernel density estimation of that specific data. The link to the video up the top right. So what I want you to really get your eyes on is that I have the kernel density estimation up the top in this graph for this data, and the violin plot looks exactly like that. If I rotate this image, you will see that the violin plot on both sides shows the mirror of kernel density estimation on both sides, which is really helpful. I can easily look at a violin plot and say, yep, I can understand that this data is pretty much evenly distributed, because here is the center point at 0. The amount of data up the top equals pretty much amount of the data down the bottom in the negative side, which is your kernel density estimation. Let's get our hands dirty with this. A super quick note about Seaborn. So in Seaborn, we have 3 main functions: relplot for relational analysis, the displot for distribution analysis, and catplot for categorical analysis. Today, we're looking at the violin plot. In Seaborn, you don't really need to go down the barrel of smaller functions. If you use these 3 and you know what type of plot you want, you're good to go. Let me show you how. Let's make a Jupyter notebook, give it a proper name, Seaborn_10 violin plot. I really encourage you to name your Jupyter notebooks properly based on dates. I'm not putting any dates on these Jupyter notebooks that I'm making, but when you're making your own ones, make sure you name them properly and preferably put a date on them so that you can find your stuff easier later. Import Seaborn as SNS. That's the only library I'm going to be using today. I'm going to be loading the tips dataset. So I'm going to use the load dataset from Seaborn and load the tips data. If you haven't seen my previous videos, here is the tips data with 5 top rows that I'm showing here using the head function. There is the total bill, the amount of money customers spent in a specific restaurant, how much they tipped, what was their sex, were they a smoker or not, what day of the week were they visiting this restaurant, and what time did they come for lunch or did they come for dinner, and what was their size of the guests. So were they 2 people, 3 people, and so forth. So we are trying to understand how much money these people tipped to the staff of the restaurant, and does it really matter if they're a male, if they're a female? Are smokers more generous than non-smokers? Do on Sundays people tip more? This kind of understanding from this data. So you can do the same for your own data. I'm going to use SNS Catplot because, as I told you, I want to use first the top function, and I'm going to go down and use the violin plot itself as well. For now, for starters, let's start with Catplot. Use the tips data that I made here, and I want to set on the x-axis, I want the total bill. It will give me a strip plot. because if you look at the default of the Catplot, the default is a strip plot, which is a type of scatter plot, the link up there. But if I want to get a violin plot, I just need to say kind equals violin, and that will take a bit of time, but will give me a violin plot. So as I told you in the theory, violin plot is the mirror of the KDE plot. So let me quickly show you SNS KDE plot of exactly the same thing. I don't need the kind violin, and I'll just copy the data right here. So it might be visually just a bit different, but trust me, the top half of this violin plot is exactly this KDE plot, and I will fill it in blue so that you can see it. This is exactly the top half, and if you invert it, the bottom half is the inverted form of the KDE. Let's trust me there. What can we do with this violin plot? One, if you want to invert it along the y-axis, you just, instead of saying x equals total bill, say y equals total bill. And now that actually looks like a violin. Here is pretty much the middle, and that's the KDE plot of the total bill. Would I be able to look at the tip? Yeah, I can see that a lot of people tipped between $0 to $4 because that's what on the y-axis, and then there were people that were really generous and tipped around $10. Let's go back total bill. A very interesting thing you can do is actually the visualization in the center of a violin plot. So by default, it comes as inner equals box. So this is not going to change it because I'm actually doing the default. But if I change it to point, what it will do, it will actually show the data in the middle of the violin plot. Can I change it to something else? Of course. If I change it to quartile, it will show me the first quartile in dashed line, the median, which is the second quartile in the middle, and the third quartile in another dashed line. Can I get something different? Yeah, you can show the sticks, which shows the density of how much data is there on that plot. Remember how there was point? So points are really dense. Change these points to sticks along the y-axis. So if I put sticks here now, they will represent the same points, but in a different format. Okay, let's move it back to box. Here, I'm not doing any comparison. I'm not really understanding if sex matters in amount of tip people receive. I would like to understand if females or males, whichever, tip more compared to the other sex. What I will do, I have the y-axis, which is the amount of total bill, and I will change it to tip because I want to study the tip. On the x-axis, I want to add the sex variable. What it will give me, it will give me a violin plot for the male people who came to this restaurant and another one for females who came into this restaurant. Now for me, it's easier to understand how much money is being tipped by these guests. So really quickly, I can see that the distribution is pretty much the same. They look pretty much the same. However, there are a couple of generous males that are changing the distribution for males in tipping. And would I be able now to break it even further and say, tell me what is the smoker male community doing as opposed to non-smoker male community, and smoker females as opposed to non-smoker female. Let's do that. Let's add a hue. I'm just going to move kind and inner to the next line so we don't really get it mixed up. Let's add a hue of smoker to this graph. And what I have now is the male community two graphs on the left, smoker, non-smoker, female on the right, smoker, non-smoker. So a smoker is in blue, non-smoker is in orange. And very weirdly, smokers seem to be tipping more in both sexes. This is one way of showing this. Number two, if I set the dodge value to false, which is not really smart, they will plot on top. Smokers and non-smokers get plot on top. What is it good for? I can see the differences, but only if the one at the back is bigger so that I can see the one at the front. If it is the opposite, I will not see anything. So what can I do now? All I need to do is to say split equals true. And I don't even need dodge equals false. What split equals true does, it gives one half of the violin plot to the smokers and the other half to the non-smokers. Now, it is very easier for me to see that the male community, blue and smoker, orange non-smoker, female community, blue smoker, and female non-smoker. So I can easily present this and give summary of this data to anyone who is interested. So far, I was using the Catplot function, which is this top function. Now I want to use the violin plot function itself. It's exactly the same thing. So in your Jupyter notebooks, copy everything from the Catplot, paste it down here. Just remember, you don't need to say the kind equals violin because you're gonna use violin plot. So you don't need to say this kind is violin. I'm gonna delete this. I am gonna get exactly the same graph using the violin plot function. Because I don't want exactly the same thing, I'm gonna say, let's study total bill on different days and yeah, between smokers and non-smokers. How about this? Okay, now this is a different graph. I'm looking at Thursdays, Fridays, Saturdays, Sundays, smokers in blue and non-smokers in orange. Every single day, smokers are tipping more compared to non-smokers. What if I wanted to change the color palette? Very simply, just go to palette equals, for example, set 1, which is this color. You can set 2 if you want to. You can set the grays, you can set the greens, and so forth. And I want to change the visualization in the center of the violin plots. What I will do, I'm going to change inner to stick so that I can see the sticks. And final part of this video, how would I present this? What I'm showing here on the screen is the graph of the total amount of money people spent in a special restaurant on 4 days of the week, starting from Thursday to Sunday. From what we can see, 2 shades of green represent if the customers were smokers or not. Smokers being on the left side of each violin plot and non-smokers on the right side. The tick marks inside the violin plot shows the distribution of data for that specific violin plot. What you can see is that Thursdays, Saturdays, and Sundays are pretty much the same in terms of how much money people spend from min to max, by Saturday extending on a larger bill range. However, Fridays are a weird one. 1, because they don't have a lot of customers. 2, the amount of money spent by non-smokers has a really smaller range compared to other 3 days. If I were the owner of this restaurant, I would really concentrate on Thursday, Saturday, and Sundays, but also I would think of Fridays on my promotion day. I hope you enjoyed this video. If you did, please hit the like button, subscribe to my channel, and help me grow this. Thank you.